Lecture 1.2, Day 1, Functions and Graphs. Our first slide is of the Parthenon. You might remember that the Parthenon is in Greece. However, this Parthenon is in Centennial Park, Nashville, Tennessee. It was built in 1897 for Tennessee's centennial celebration. Inside is a giant statue of Athena holding a smaller statue of Nike. Athena Parthenos is 41 feet 10 inches tall. It is a replica of what the statue in the original Parthenon might have looked like. This statue was completed in 1990 and gilded in 2002. We will start our study of calculus by spending a few days in a quick review of several pre-calculus topics. Whether you are comfortable with all of these pre-calculus topics or have forgotten many of them and have to learn them now, it is okay either way. The most important thing to remember in your study of calculus is this: don't panic. Calculus is a challenging class for everyone. If you ask questions, keep up with the homework, and study for quizzes and tests, this will be the best math class you have ever taken, and you will be proud of your success. And college will be way more fun if you have taken calculus in high school and don't have to stress over passing your first college math class. Domain and range. Functions have an independent variable, often x, and a dependent variable, often y. In this discussion, we're going to use x for the independent variable and y for the dependent variable, but we could use other letters. Domain is the set of all possible x values for a function. Range is the set of all possible y values for a function. We can specify the domain of a function, or we can look at the nature of the function to determine the natural domain of the function. Example, find the domain and range of f of x equals 1 over x. When finding the domain, it is often easier to think of what values that we cannot use for x. In this case, x can't be 0 because we'd get a divide by 0 error and our calculator would probably blow up. The domain is D is a set of all x's such that x cannot equal 0. This is set builder notation. Or we could write D equals the interval from negative infinity to 0 combined with the interval from 0 to infinity. We usually use interval notation in calculus, and notice that we use an open interval parentheses because we don't count the 0. Also notice the symbol for union. Now, if we draw the graph, we see that we can have every value except 0, so the range is the interval from negative infinity to 0 combined with the interval from 0 to infinity. Another example, find the domain and range of y equals radical x. Since we cannot take the square root of a negative number, the domain is D equals the interval from 0 to infinity. This is a half open interval. We use a square bracket on the left boundary point because we count the 0. The interval is closed at 0. When infinity is a boundary, it is always an open interval on that end with parentheses. Drawing the graph, we see that we get half of a horizontal parabola. Looking at the graph, we see that there are no negative y values, so the range is r equals the interval from 0 to infinity. And it's a closed interval at the 0 because we count the 0. Symmetry. When we graph the function y equals x squared, we see that it has y-axis symmetry. If we cut this out of a piece of paper, we could fold it in the middle right on the y-axis. When we square the x, any negative sign cancels out, so changing the sign of x does not change the y value. Any polynomial function with only even exponents behaves the same way and has y-axis symmetry. In this example, y equals x to the fourth minus 2x squared minus 1. We have two even exponents here and here, but also 1 is x to the 0, which has an even exponent. Any function with y-axis symmetry is called an even function. For example, y equals the absolute value of x is an even function. We get our familiar v graph. So is cosine x. Cosine x has y-axis symmetry, behaves like a polynomial with even exponents, so it's considered an even function. A polynomial function with only odd exponents has origin symmetry. Changing the sign of x changes the sign of y. For example, y equals 1/2 x cubed. In other words, if xy is on the graph, so is negative x, negative y. Here, 2 4s on the graph, and so is negative 2, negative 4. Any function with origin symmetry is called an odd function. For example, y equals sine x is an odd function. Polynomial functions with exponents that are both even and odd have no symmetry. Of course, a graph with x-axis symmetry is not a function at all. X equals the absolute value of y fails the vertical line test, so it's not a function. Piecewise functions. While many functions can be defined by a single formula, others are defined by applying different formulas to different parts of their domains. For some reason, some students are a little apprehensive when it comes to piecewise functions, but you'll find they're really pretty easy once you learn the trick. For example, y equals f of x equals negative x when x is less than 0, x squared when x is between 0 and 1 when x is greater than 1. Just graph each piece separately for each part of the domain. So it's negative x for that part of the domain where x is less than 0, and we graph the line y equals negative x. It has a slope of negative 1. We use the x squared graph where x is between 0 and 1, and you recognize the x squared graph as a parabola. So we graph a little piece of the parabola. And finally, y equals 1 when x is greater than 1. And y equals 1 is a constant function, so it's a horizontal line. We draw a horizontal line to get the entire graph. Example, write a piecewise function for the graph at right. There are two pieces to this graph, so we need two equations. The equation for the left-hand piece is y equals x. We see it has a slope of 1. For the right-hand piece, the equation is y minus 0 equals 1 times x minus 1. So we use the point slope formula, and we use the easiest point, which is 1, 0. We got the equation for that line. This simplifies to y equals x minus 1. Paying attention to the open and closed circles, we get the piecewise function f of x equals x, where x is between 0 and 1, and x minus 1, where x is between 1 and 2.